Hello? Yes, it works. Fantastic. Thank you very much for coming. And I'd like to talk about Iceland today once more. But today I'd like to talk about Iceland in its entirety and about the origin of Iceland, not just about the recent eruptions, but I'm going to introduce some concepts about how Iceland formed, why it is where it is, and how it all came about. And then I'm going to introduce you to the Champions League of Icelandic volcanoes. And then we're going to talk a little bit about the pros and cons of volcanoes as well, what is good and what is not so good about volcanoes. Because like everything, there's good sides and there's bad sides about volcanoes. So I call it the journey from the center of the Earth, not to the center of the Earth, as Jules Verne called it, because magma obviously rises from the interior upwards. And it's a probe for us geochemists and geologists to look into the interior of the Earth. So where are we? Well, we're pretty high up on the globe, and this is where Iceland is, and we are just about here, close to the Faroe Islands right now. We're just outside this red box here. And, well, Iceland is an intriguing place because it combines ice and fire. So here we have these two components that make Iceland so special. And Iceland sits on a mid-oceanic ridge, and in particular the mid-Atlantic ridge. This is where the Atlantic spreads, and it spreads on a continuous basis. It spreads every day just a tiny little bit, and this ridge actually spans all around the globe, and it's about 60,000 kilometers of volcanic ridge. And most volcanism on the whole planet happens along these ridges. 84% of all volcanic activity is submarine along these mid-oceanic ridges. So Iceland is in the heart of this spreading zone, this mid-Atlantic spreading zone, and we can see the spreading zone here, and it continues to the north as well. And Iceland sits right on top of that, and of course this means we can see the spreading zone on land in Iceland, and this is the Reykjanes Peninsula, and it moves via a complicated network of spreading zones all through the center of Iceland. And here you can see the plate boundary between, well, the North American plate and the Eurasian plate on either side of it. And the spreading is, well, it's about 2 centimeters a year. And I usually tell my students, that's about the speed with which your fingernails grow. So this is how fast the Atlantic spreads. The Pacific is a much older ocean. It spreads a lot faster. It spreads at 7 centimeters a year. That's about the speed with which your hair grows. So you can get a sense for that. So here we have the oldest rocks in Iceland, and they are here at the fringes in the very east and the very west. And this is where we had a port day just before we sailed off towards the east. And Iceland's oldest rocks are geologically very young. They're only about 12, maybe 14 million years old. And when we think of rocks in Sweden or Norway, which are thousands of millions of years old, the rocks in Iceland are extremely young. So, but here's one of these questions that I find personally very intriguing, and that is, well, we have these long segments of oceanic rift zones. They go through the Atlantic and through virtually all the other oceans as well, but only on Iceland do we actually see them above the water level. So what's so special about Iceland? Well, and I hinted at this yesterday if you were here, the thing is that Iceland is not just a spreading ridge, it's not just a plate boundary, there's something else going on. And we call it a plume, a mantle plume, or some people call it a hotspot. This is very similar to what we have under Hawaii, but also many other places, like the Canary Islands, the Azores. There we have an anomaly that comes from deep inside the Earth, and it rises up, and it just happens to coincide with this oceanic spreading ridge, and that makes Iceland so unique, so special. So here we have a spreading ridge that is hit by one of these deep-seated mantle plumes. And Well, these spreading ridges, they usually start off somewhere in the continent, and we have one like this. It's the Rift Valley in East Africa. It looks like this. We don't have an ocean there yet, but the plates are spreading apart, and once they have spread to a sufficient degree, we actually start having water flooding in, and then eventually we make a large ocean with a ridge in the middle. But here you see Iceland in the middle of the Atlantic Ocean. Here's Greenland. Here is the British Isles. And here is Iceland along the ridge. And it sits here, and there's a swell of ocean rocks underneath, and it continues all the way to Greenland and to the British Isles. And there we have volcanic rocks that are very, very similar to the ones on Iceland, only they're much older. So this Icelandic plume was there for a long time. It must have been there since the beginning of the Atlantic Ocean. And the rocks are present here in East Greenland, as well as in the Hebrides and in Northern Ireland. So we have initially a plume that came up, and it hit the areas here in Greenland when the Atlantic was still together, and at the same time here in the British Isles. And then the Atlantic started to spread, but the Icelandic plume maintained its position. It was strong for many millions of years since the Atlantic started to form, and it's still going strong at the present day. So, having talked about this, well, people have reconstructed how this concept of plumes work, and the first person who really thought about mantle plume was actually Athanasius Kircher in the 1670s, and here's his drawing. He believed that there was a fire inside the earth and it would rise up and make volcanoes here. It was heavily disputed at the time, and a lot of people didn't believe him. But today we're looking at it in this way, and actually he wasn't so far off. I'm actually quite impressed with his thinking. And this is a reconstruction. This is the present day. This is 30 million years ago, 60 million years ago, and this is 90 million years, 120 million years ago, and this is about 150 million years ago. And when we start there, this is about when the Atlantic started to form. There was two of those plumes, one of them the Icelandic plume, and one probably sitting somewhere under Greenland, and eventually these two merged, and they give rise to the present-day Iceland plume, and it's still going strong to the present day, and for all we can tell, it'll continue to do so for quite some time in the future. So where do these plumes come from? Well, we really actually know only a little bit about them. It's very complicated, but we know that there are subduction zones, for example, in the Cascades in the US, but also in Japan and Indonesia, and their material is pushed down into the mantle, and we can image this material sinking all the way down. And once it rests there for some time, we believe that it heats up from radioactive decay, and then it might actually rise up again. These are very long processes. They take thousands of millions of years, and we believe that these plumes come from very deep, from what we call the lithosphere graveyard, down here at the core mantle boundary. But of course, nobody has ever been there apart from Jules Verne, and therefore we are speculating, I have to admit, but the chemistry of the magmas coming up, they tell us that something like this must be happening. So, we believe that these plumes come from ancient, lost continents that are long, long gone. We don't see them at the surface anymore, but remnants of them may still be present deep within the earth. So, when we move this material up now, then this plume hits this area where we have Iceland at the surface, and here's a reconstruction from a depth of about 500 kilometers, and this is a very simplified sketch of it. The center is believed to be sitting right under the middle of Iceland, and in reality it's a bit more complicated, but here's the surface expression, and it seems to have a narrow stem in the middle, but it's a bit of a wider zone that is affected, and this wider zone initially, as I said, was causing some volcanic activity in Greenland and the British Isles, but now it seems to be very narrow, focused almost exclusively on Iceland. So when this magma then rises up, the plume material spreads out, and eventually it starts to make magma reservoirs in the crust. And this is now very close to the surface. There we are producing magma chambers. And, well, chamber is one of these terms. It's not in fashion anymore. We call them now magma reservoirs, because chambers are empty, and magma chambers shouldn't be empty. They should contain magma. So magma reservoirs. And then we have all these ascent paths, the conduits, and depending on what their orientation is, we have different names for them, sills and dikes and etc. And eventually they feed volcanoes at the surface. But we must be aware only a fraction of the magma ever reaches the surface. Most of it gets arrested inside these islands, inside Iceland, and actually the uplift of Iceland is stronger than the volcanic production. So there is probably at least 50 to 70% of magma that is never reaching the surface, but is actually placed inside the island itself. So this now leads to this strange interaction between the fissure zone, the rift zone that we see at the surface, and all the way down into the southern Atlantic and, of course, into the northern Atlantic. And this area is where most of the volcanoes are, and this is where we believe this plume just hits this oceanic ridge, giving rise to some 30 larger volcanic systems. And here's a list of all the important volcanoes, all the Champion League players in the Volcano League. And we don't have to go through all of them. I'll just introduce you to some of them. Some of them have very complicated names. Others are a little easier to pronounce. But my goal is now to give you the most important ones and a little history to each of them. So before we do that, I should point out there's two core types, and this is central volcanoes. These are usually the cone-shaped volcanic edifices, the stratovolcanoes. And in Iceland, because of this rift system, we have fissure volcanoes. These are volcanoes that form along cracks in the earth crust, and they behave a little differently. They're not less dangerous, they're just different. So, and before we plunge into our Volcano Champion League, here I should point out each of the volcanoes has a slightly different character. There is no volcano that's exactly the same as another one, like humans, and they come with different hazards. There's proximal, distal, and temporally extensive hazards. Some of the features happen on the scale of hours, some take days, weeks, and others, like climatic effects, take years. The local effects are usually lava flows, but also ash clouds and landslides, pyroclastic flows, hot ash clouds, and then also mud flows. And these features, they are usually happening on the scale of hours to days. Sometimes they take weeks, while these climate effects, like changes of weather, for example, they often take years, and they can be detected several years after a large eruption. So, but let's start with one of my favorite volcanoes, Sn&aelldr. And Sn&aelldr sits here. Oops, there we are. Sits here, and this is going to be the most westerly volcano we're going to look at. And I like it so much because this is where Jules Verne had Professor Liedenbrock find the entrance to the center of the Earth. So, if you go there and you look carefully, you might find it yourself. I had a look and I failed, to be honest. So I never managed to go to the center of the Earth. But the idea, according to Jules Verne, is that if you go all the way down, you can come back up somewhere else. And in Jules Verne's description, it was Stromboli. So Professor Liedenbrock and his team came back up in Stromboli. And Jules Verne was quite perceptive, and we are laughing about it. But he noted that volcanoes may be connected deep inside the Earth. And that's an important realization. So this is a strange zone that sticks out here, and it's called the Snæfellsnes Peninsula, and this is a separate volcanic ridge, and here we have the volcano itself. Usually it's snow-covered, and it's a little peculiar, and this is probably why Jules Verne chose it for his novel Journey to the Center of the Earth. So then I'd like to move you down to the Reykjanes Peninsula. This is a bit further south. And we talked about Fagradalsfjall yesterday, a rather unknown volcano until about 2 years ago. And it sits on the Reykjanes Peninsula, only about 40 kilometers from Reykjavik, very close to Reykjavik. And it's a ridge-like system. It's an elongate volcano, and it had an eruptive pause of more than 800 years on the entire Reykjanes Peninsula. And now this new eruption causes concerns that the Reykjanes Peninsula might wake up again and become volcanically very active, given that there is Keflavik Airport, Reykjavik itself, the Blue Lagoon. The highest population density on Iceland is actually on the Reykjanes Peninsula. This is, of course, a cause for concern. And here's just an image from across the bay. You see Reykjavik here and the eruption just here and the big eruption cloud. So this gives you a sense of the proximity of the volcanoes next to the capital here. So, some spectacular images, and Fagradalsfjall was good for a number of reasons. During COVID, the tourism industry was suffering really badly in Iceland, and spectacular features. Here you see the lava running into valleys, and literally thousands and thousands of people came to see it, and it's believed that the volcano saved the tourism industry, avoiding another financial catastrophe like in 2008, where Iceland suffered dreadfully because of the financial crash. So, and here's just a few impressions. Here you see the lava lobes coming out, and this is from 2021, and here you see the amount of people. And this is a rescue worker, and the authorities were really, really relaxed about things. You could go really close to the lava. People were actually having barbecues on the lava, believe it or not. I tried it myself, but I actually felt it was a little gritty, so it wasn't all that tasty. So, and then it paused for a few months, and then in August 22, the volcano came back, and it had another few weeks of eruption, but it was a little smaller then, and this is what we talked about yesterday. And there, it's a beautiful little eruption, and hopefully it doesn't develop into something bigger, and hopefully it doesn't affect any major infrastructure. So let's move on to another big shot in the volcano world in Iceland, and that's Hekla volcano. Hekla was traditionally believed to be the entrance to hell. So here you see Hekla in this old map, and here you see the fires coming out. Hekla also gave rise to a lot of sulfur mining. Gunpowder for the Danish and the Swedish empires was actually sourced from Iceland. And it's a stratovolcano about 1,500 meters tall, and it's one of the most active volcanoes on Iceland. And it had something like 20 eruptions since the settlement period on Iceland. And during the Middle Ages, as I said, it was considered the gateway to hell. So there was major eruptions, and one of them in 1104, they was used by monks to point out that Iceland is a bad place, because Iceland was not fully Christianized by then. So it was a propaganda ploy by monks all over Europe to call Iceland the gateway to hell. So trying to say people there are not quite good. So, and well, Hekla is the word for a short hooded cloak, and you can just about see it here. Sometimes Hekla has this cloud on top. It's a bit like a hood, and this is where the name apparently comes from. And here you see some old drawings with Mons Hekla, the mountain of Hekla, and this is the chaos. You can read it here. This is where all bad and evil originates from. The most recent eruption of Hekla was in February 2000, so it's been dormant for about 20 odd years, and well, let's hope it stays dormant a little longer, but of course it could come back any time. Then I'd like to move you down here to Heimaey, and some of you have been there, I understand. It's a little island group there, the Westman Islands, and well, Westman is actually, well, we can still read it today, it's the man from the west. It's an old Icelandic name for Irish people. a lot of Irish slaves were taken by the Vikings when they came over, and there was this strange situation that some Irish slaves were increasingly unhappy with their master, and they got into a fight with the master, and they killed their master. And they had to escape, so they escaped to the Westman Islands, which weren't called the Westman Islands then, but there is a saga then that the son or the brother, I think, of the master then set out to hunt them all down, and so he did. And all the Irish slaves had only a short spell of freedom in the Westman Islands, and apparently all of them were killed. So it's also the site of a pirate attack. There was pirates from North Africa, believe it or not, coming all the way up to Iceland, not just to Britain or Ireland, where we also know of these North African pirate attacks. There was one in 1627, and they captured a whole bunch of local people and brought them into slavery for the Ottoman Empire. So, but there was a big eruption in 1973. I was only very small at the time. Some of you might remember it. And there we have the big eruption of Eldfell, which is the volcano on the island there. So here's a photo with Eldfell spewing fire. And this is Heimaey. And there we have the harbor. And you see this knob here. This is Eldfell volcano over there. And this is the lava from 1973. And there was big concern that the lava would close the harbor basin and therefore ruin the economy of the island. So what happened was that the local people sent fireboats out there, and they hosed the lava in an attempt to cool the lava down. And urban legend has it that they managed to stop the lava from filling the harbor basin. It's a wonderful story, but in reality, if the lava wants to fill the harbor basin, it will fill the harbor basin. So it happened to be more of a coincidence that they just sprayed water on it when the lava was already slowing down. So here's a few images, and this is the harbor basin. Here's Eldfell, here's the city, and here you see the lava progressing into the harbor basin. And of course, when lava meets the water, you get all sorts of reactions, a lot of steam, and sometimes even explosions. But eventually, the lava stopped, and the harbor is still useful, or is still in use to the present day. So here is a little map. This is the airfield, this is the volcano, and this is how the lava progressed. And luckily for the population, the volcano stopped just in time before economic ruin occurred. So here's a few impressions from back then. The city was, of course, evacuated, and nobody died apart from one rather peculiar accidental case where somebody snuck back into the evacuated zone and died there. But this shouldn't have happened. So, but otherwise, nobody got injured. Now, Surtsey, some of you might remember Surtsey as well. Surtsey is a little island that happened to start growing off Iceland in 1963, just south of Iceland in November 14th. And this has been quite a phenomenal situation because, well, it grew to about 130 meters above sea level, and it allowed scientists to witness the formation of a volcanic island. And it also caused a lot of magma, water reactions and explosions, and we still refer to these explosions as Surtseyan eruptions since those days. And the island is still there, and it's a beautiful natural laboratory. You need permit to go there. You can't just go there yourself. And they have actually drilled into the island now as well, so we have learned a lot about how volcanoes, how new islands form. And Surtsey is still going strong. It's still there, although it's shrinking. Wind and waves are wearing it down. And, well, if there's no new eruptions, sooner or later, it will disappear. And this is why this is very important now for us to study. I should point out, we had this experience before. And there was this new island which happened to grow in between Sicily and Tunisia. And it started to grow in 1831. And within a few days, The Italians were there, the French were there, the British were there, and the Spanish were there. Everybody put a flag on it. And they gave different names to it. Some called it Fernandina, the British called it Graham Island, Ile Julia, the French. And the sad thing was, it disappeared less than a year later. So here's a drawing of Graham Island, and here's a plaque that was put up, and now it's, of course, underwater. So, and this is so spectacular about Surtsey, it's actually still there. We can still study it, but it might not be there forever. So, this is what we have learned from it. We know how the interior of these oceanic volcanoes looks like. And if you have a big island, then you can't actually look at the very base of it. So this is what we have learned from Surtsey, how the very start of an ocean island actually starts to come about and looks like. So now, this is one of these fascinating volcanoes that sits in the south of Iceland, Eyjafjallaj&ouml, and you might remember it. It caused a lot of pain in 2010, and certainly I remember it because I happened to be in France with 30 students, and everything was shut down. It's the only time I really went to the upper limit of my credit card because I got train tickets for all my 30 students. And I've got them out of France and into Germany and eventually back to Sweden. And there was a train strike then as well on the way. So I had a really jolly good time there. So Eyjafjallaj&ouml, it really is, as the name suggests, it's actually the glacier next to the islands. And it's the Westman Islands, and it sits here, and the Westman Islands are just there, so this is how the name comes about. And it was also rather unknown until it erupted in 2010, and here you can see the big eruption cloud. The eruption started quite gentle with a bit of lava, but then inside the volcano there was a pocket of more gas-rich magma, and once the new magma hit that gas-rich magma, all hell broke loose, and these huge ash clouds emanated from the volcano. And this is how they looked like, and of course they spread all over Northern Europe and actually into Central Europe as well. So I have a little video here. Let's see if I get this to work. So this gives you a sense of the intensity of the eruption back then. And this is another little video, and I put a little time function in there. Let's see if I get this to work. So this is slow motion now, and see that bit here flying out? And that's real speed. So this just gives you a sense of the intensity of the eruption back then. Although in the volcano world it was not a huge eruption, but the ash cloud spread all the way from Iceland into Northern Europe, affecting not just Scandinavia, but also Germany, France, and many other places. So here's the progress of the ash cloud swinging around in the Northern Hemisphere. And this was very, very difficult for Europe at the time. So here, this is the area affected: Germany, Netherlands, southern Sweden, and the UK, of course, Ireland. And it was so difficult because this, what we call the blue banana, is the economic core region of Europe. This is where all the important industries sit. If you drive any of the fancy German cars, it's made in that corridor, and it goes all the way from northern Italy through Switzerland, through Germany, France, the Netherlands, into the area around about London. And this was, of course, exactly in that corridor here, and it was really causing severe financial losses at the time. A little volcano eruption in Iceland causing a lot of damage, financially speaking, all over Europe. So now the neighbor of Eyjafjallaj&ouml is Katla, and Katla is much bigger than Eyjafjallaj&ouml. So we have not seen major eruptions from Katla in the recent history. The last eruption was 1918, and there is a good tephra record, a good ash record that tells us Katla has been quite active over historical times, and it sits under a glacier. So we don't see Katla really well. We don't fully understand Katla because it's hidden, but we know it's one of the biggest CO2 emitters on the planet. We estimate that it's responsible for about 4% of all the volcanic carbon dioxide emitted. Now, let me stress, volcanic carbon dioxide is still only a tiny fraction of all the emissions, and it is dwarfed by human emissions. But nevertheless, Katla is one of the big players in the CO2 emission range for volcanoes. And here we see a little photograph from 1918. This was the eruption back then. So Katla sits on the glaciers, as I said, and there is speculation it might be connected to Eyjafjallaj&ouml somewhere at depth, but maybe not. We're not entirely sure, because there was worries back then in 2010 that Katla might wake up as well, but it didn't. So this is actually good news. So how they connect, we're not entirely clear, and let's hope for the best that they're not connected at all, certainly not in the upper tens of kilometers. So this is the glacier, and there's a big caldera underneath the glacier, and this is where some subglacial eruptions may happen, but they would not necessarily translate in any major way to the surface. But it's very famous also for the glacial caves. You can actually go up there onto the glacier, and there are some caves. If you ever have a chance, I recommend it. So here's some of these glacial caves. They're quite spectacular. So then I need to talk a little bit about fissure eruptions. We looked mainly at central volcanoes, and here the oldest historical fissure eruption of significance is the Askja fires. Eld is Icelandic or Old Norse for fire, and Askja is the fire canyon. So here we have a fissure that erupted, and here you see that in an aerial photograph. It's a segment of a fissure about 40 kilometers long, and it erupted in the 930s. The exact date has been disputed for a long time, and we are not entirely sure how long the eruption lasted, but probably it lasted for several years. And it's believed that the Askja eruption stopped the settlement period. So settlements in Iceland started around 800, a little later, and the first wave of immigration to Iceland was abruptly halted, and is likely because of the Askja eruption. People didn't want to come anymore when they heard about the big eruptions there. So the Askja eruption was likely also inspiring the writers of the Edda, the Old Norse poetry book. And here we have several descriptions in the Edda, and they're not directly referring to volcanoes, but if you read it carefully, it sounds terribly like volcanoes. So the Askja lavas reached the coast, and the eruption was followed by 3 harsh winters. There was a climate effect for several years after the eruption, and people nowadays believe that this was the inspiration for the Fimbul winter in the Edda. This is the bad winter when things all break down, when the world of the North gods breaks down. And in the Edda it reads, there will be a winter with the greatest frosts and keen winds, and the sun will do no good, and there will be 3 of these. So I think there was certainly oral records of the Askja eruption, and this was inspiring the writers of the Edda. And here there's more descriptions which are quite colorful. So here in the Edda it says, the sun will turn black and land will sink into the sea. The brightest stars will vanish from the skies. Fire will rage forth, and the flames will lick the heavens itself. Boulders will slam together so big that trolls will tumble, and man will tread the path to hell. It sounds like an intense, very long, very unpleasant volcanic eruption. And we were eventually able to date the eruption because in the North German Saxon chronicles, there was also a reference to that. And it was very important because back then, this was the first Saxon king in the Frankish Empire. Prior to that, it was Frankish kings, and it was very important in the Saxon Chronicle to say that he was so important. And it helps us because it reads there, in the years just before the death of King Heinrich, and this was 936, many signs occurred. The mountains of the north are said to have erupted in flames in many places. And given that years here implies 1 to 2 years, we actually have a date for the eruption itself now. So, there was a younger fissure, and this was also very unpleasant, the Laki fissure, 1783 to 84. It erupted in 1783 to February 84, and it produced a lot of fluorine-rich clouds. This contaminated the soils locally, and a lot of livestock in Iceland perished. And it's believed that a quarter of the population of Iceland perished as a consequence of the death of all the livestock. We estimate that 25,000 people on Iceland perished because of the consequences, not directly from the eruption, but because of the consequences. And there is records from Northern Europe that these fluorine-rich clouds reached all the way to Scandinavia. And if you look at the church records in southern Sweden, you can actually work out that the death rate was higher in those years. So, and, well, unfortunately, volcanoes in Iceland have not only affected air traffic in 2010, they have affected Europe for many, many decades, and centuries, in fact. Now, we're moving a little bit into the island of Iceland now, and I have 2 more volcano champions for you. So here's Askja, and Askja is a big volcano here in the central rift zone, in the eastern rift zone, and the name Askja refers to a nested caldera, meaning several holes in the ground side by side, and it rises to about 1,500 meters, and it means a box or little boxes that are in each other somehow. And indeed, this is how it looks. We have these larger caldera features, these vents or holes in the ground, and it's a nested system there. The area is only accessible a few months of the year. It's not a very inviting area, and I remember having been there some years back in August, thinking that that's a good time for going to Iceland. I was in the worst snowstorm I ever experienced. And it got so cold, and I was shivering so badly. It was actually it was the only occasion where I had to get my glucose pills out of my survival kit. It was that bad. So I don't recommend Askja at any time of the year. So Askja erupted in 1875, and it was a very unpleasant eruption in March 1875, and it triggered a wave of people leaving Iceland. And many of them went to the US, many went to Canada, and there's an intriguing kind of feature here. If you look at people of Icelandic origin in the US, you will find that many of them were looking for colder climates here as well. So they weren't choosing the hot areas in the US, but some people here down in the southwestern area here, they learned their lessons from coming from Iceland. So this was one of the main emigration periods starting in the late 1870s from Iceland, and Askja triggered this. So the last volcano I'd like to introduce you to is Krafla, and some of you may have seen it. We went there with the buses, and here we have a big caldera system. It's also a large power plant, so there's energy harvesting going on there. And Krafla had a big eruption, the Krafla fires from 1975 to 1984, and since 1977 there's a big power plant. And Krafla is a strange place for geologists because they drilled for geothermal energy, and by accident they drilled into a magma reservoir. People got really, really nervous, and the head scientist, he was borrowed from the US, he was from the Alaska Observatory, and he got really, really nervous, but strangely nothing happened. The drill bit was a bit melted, but no explosion, nothing. And we really had to rethink our understanding of volcanoes at that point. And now there's real plans to drill back into volcanoes, because now we've done it the first time. So now we think we know how to do it. I'm still a bit worried sometimes. But this is where Krafla comes in. We actually drilled into magma inside a volcano for the first time at this place. So now I'd like to wrap up a little bit, and I talk about the good and not so good sides of volcanoes. Now I'd like to mainly focus on the advantages. So first of all, the volcanoes are monitored. And several international organizations are in contact with the Icelandic offices. And whenever there's a big eruption, the Icelanders are very good to ask for help, and they're very experienced themselves. So, for example, last year there was colleagues from the US, colleagues from Scandinavia. They're all being brought together. Those people with volcano experience are then slotted into monitoring teams, into surveillance teams. And of course, we have ground-based monitoring, we have air monitoring, we have remote sensing via satellites. Here's a satellite image of how a volcano deforms. And this allows us to really make sure that the volcanoes usually don't cause any fatalities anymore. We cannot prevent that they will cause damage to infrastructure, but the death toll of volcanoes has been continuously going down over the last 100 years. We're getting actually pretty good at this now, as long as we invest and are prepared to put the effort in. So, but here's the two faces of volcanoes. Let's close with some positive sides of volcanoes. Well, first of all, we said tourism has saved the Icelandic economy, and the biggest tourist attraction in Iceland is the Blue Lagoon. Here's the Blue Lagoon, and actually that's, I almost not dare say it, but it's the wastewater of a geothermal power plant. And they just pour it into a little valley, and it's stuck there. And some smart Icelandic person said, let's make it a pool. And so it is, and it comes with a lot of silicon mud, and this is now marketed as well. You can use it as cosmetics. It's actually surprisingly good for your skin, because it dries out your skin. It's got sulfur as well. It disinfects the skin. So, and it's very, very popular. So geothermal energy is very, very important in Iceland, and 40% of the geothermal energy is used for generating electricity, making Iceland a haven of cheap electricity. And there's also greenhouses in Iceland, fish farming, etc. All of these things use geothermal energy, and it's cheap, it's plentiful, and it's renewable. And let's see whether I get this to work. So this is a little geothermal vent near Krafla volcano, and you get a sense it's steaming away permanently. We'd be silly not to harvest the energy from these places. So how does it work? Well, usually what happens is we take cold water, we pump it down, we have to drill holes, and this is where the accident at Krafla happened. So here's the magma reservoir, the heat source. We pump cold water down, and the water expands when we make steam of it, and this expansion is what drives the turbines, and this allows us to make electric power. But the geothermal energy is not just used to create electricity and district heating. Actually, in Reykjavik, even the streets are kept free of snow and ice in winter, because there is all the geothermal power pipelines. They are under the streets, and that keeps the streets free. And actually, these days, we're also drying fish with it. A lot of the dried Icelandic fish is actually dried in greenhouses that are heated with geothermal energy. And the greenhouses are partly also used for producing all sorts of crops. And believe it or not, Iceland has the highest banana production of all the Scandinavian countries. So, and of course, you can grow not only bananas, but also flowers and other vegetables. And here you see a tiny little graph. Hydropower is rising in Iceland. This is 2010. Coal and oil is diminishing, but geothermal is the big new energy source in Iceland. Well, I mentioned the Blue Lagoon. It's, of course, a huge tourist attraction, brings a lot of money, it's very attractive, and also the cosmetics that come from it. And if you go to the airport, for example, Reykjavik or Keflavik airport, you have large shops there, and of course at the Blue Lagoon itself. And the products are very good for your skin, as I said, and they're very popular. And strangely enough, I'm reading that they're extremely popular in Asia for some reason. So then, if you are a whiskey drinker and you don't like water in your whiskey, then Icelanders recommend you take a piece of Icelandic rock, you put it outside in winter, and then it freezes over, and then you can put it into your drink, making the drink cold without adding water. So we have no real ore deposits in Iceland, but there's some gemstones, and people work with the stones, of course, to a very sophisticated level. And in addition to this, Iceland has, of course, these extraordinary landforms, extraordinary life forms, and this is a beautiful natural laboratory for scientists like myself coming here, studying the eruptions, studying how the Earth works, studying actually how the Earth may have even started to build continental crust, because Iceland is one of these laboratories. And just to close off, Iceland also gave rise to a whole wealth of myth, legend, and sagas, and all of them somehow connect to volcanoes. Thank you very much.